Let's start this problem. A car traveling at 60 kilometers per hour overtakes another car traveling at 42 kilometers per hour. You can consider that there is a car, say this is a car, this is traveling at there is another car behind it is traveling at 60 kilometers. Behind this is say this is number 2 car and this is number 2 car overtakes the number 1 car. In fact, there will be an instant when the number 2 car will be just behind number 1 car, like this. That means the front of the number 2 car is coinciding with the rear of the number 1 car. Then, after some time, it appears that number 1 car has come here. So, overtaking is done. Question is, find the time taken during the overtake. And there is another question which we shall see more. Also, it is given each car is 5 meters long. So number 2 car actually moves 5 meters and another 5 meters. That is equal to total. In order to solve this problem, we can easily use the concept of relative velocity. Considering number 1 car to be static, number 1 car, we consider this one static. Then the relative velocity between number 1 and 2 is relative velocity is equal to minus 42 equal in which is equal to 18,000 meter divided by 3600 5 kilometer. Sorry, 5. This unit is now 5 meter per second. Right? Yeah. But second car moves actually 10 meter. So if it has to move 10 meter with a speed of 5 meter per second, so obviously the time taken is equal to 2. So this is one answer. Time taken is 2 seconds. Then the second question is the total road distance used for the purpose of overtake. The total road distance is actually from here to road distance is here to here. Now we consider the actual speed, not a relative speed, the concept of actual speed. In fact, say when the overtake starts, the first car was here and the second car was here when the overtake started. But When the overtake is complete, the first car is somewhere here, and the second car is so in these 2 seconds, the first car has moved from here to this is time is 2 second time. So now we have to find out how much distance the first car moves in 2 seconds. The velocity of the first car is 60 kilometers per hour. So it is 60 L2 60 multiplied by 1000 divided by 3600 by 10%. Absolute velocity of the second car is 600 100 by 6 meter per second. So the second car took 2 seconds to complete the overtaking. So in 2 seconds, it moves 2 multiplied by 100 by 6 is equal to 100 by 6 meter. Also, the road distance should include this distance. That means another 5 meter, because the rear of the second car was here, and the well, this is the distance. So it will be actually 200 by 6 plus 5 meter. This, if you calculate, it will be 38.33 meter. Total road distance. Okay. Now, shall go to the second problem. This is another problem. This problem says a stone is thrown upward vertically with a speed of 28 meters per second. This is actually a very simple problem with a little trick. So what it says that this is the ground and the stone is thrown vertically upward, straight upward. Let us say the stone reaches this point. Let us say the stone reaches this point. Let us say this height the stone reaches is h. So while going up, the stone goes in this direction. While coming down, the stone follows the same path and comes down. Also, we know that final velocity v of the stone is 0 when it reaches the maximum height. The first question is, find the maximum height reached by the stone. Answer to this question is quite easy. You can use this equation, kinematics of vertical motion. This equation, then final velocity v is equal to 0 is equal to square. It was thrown upward with a velocity of 28 meters per second. So u square is 28 square minus 2. T is 9.8 meter per second square, and h is to be formed. Therefore, we find h is equal to 58 square divided by to calculate this, we will find it is 40. So this is actually the answer to the first question. There is a second question. Find the velocity of 1 second. Find the velocity 1 second before it reaches the maximum height. Now, the body reaches the maximum height here. Find out where. Now, just 1 second before it reaches there, let us say the body, the stone was here. 1 second. This duration, time duration, is second. Question is actually a little bit tricky, but very, very easy. Let us say, time taken to maximum height is equal to, in that case, we use this equation to find out the time. At the maximum height, the speed is 0, is equal to u is instead of writing 28, let us write u minus g t1. So from here, we find t1 is equal to u by g. 1 second before t1, 1 second t1 is actually 1 minus 1, which is equal to u by g minus 1 minus 1th second. 2 by g minus 1 second. Now, we shall find out what is the velocity at this time, u by g minus 1. Say the velocity at u by g minus 1 is equal to, in that case, what is v1? v1 is equal to, again using this formula, u minus g time t1 is equal to u minus g. t1 is u by g minus 1. u by g minus 1. This is equal to u minus u plus g. So this is equal to g. That means velocity 1 second before it reaches the maximum height is g, which of course is equal to 9.9.8 meter per second. Now the question was, does the part B answer change if the initial speed is more than 28, such as 40 or 80? Answer to this question, since the uh, 1 second in the maximum height is dependent of u. So no change. That means if the initial velocity is not 28, anything, whatever it is, the speed at 1 second before reaching the final line will always remain g. So there is no change.